So the first thing to know is the name of the shapes based off 3 sides, 4 sides, 5 sides, 6, 7, 8, 9, 10, 12. And anything past 12 we usually just call it, like if this was 17, we call it a 17 gon. 18, we call it an 18 gon. And so we have a polygon, and if all sides are congruent and all angles are congruent, we call that regular. And then a polygon is blank if all of its diagonals lie in the interior. We call this convex. And a polygon is concave if all or part of at least one diagonal lies outside the polygon. So here, notice we call this shape regular. We call it regular because all 4 sides are the same. Another word for that is square. Here, we call this irregular because, yes, the 4 sides are the same, but the angles aren't the same. So we call it irregular. Here, we have this side equal to this side, that side equal to that side, and then this side that's completely different. Because all sides aren't the same and all angles aren't the same, we also call that irregular. Now the difference between convex and concave is if the polygon makes a cave, like something you could kind of walk into and hide out, we call that concave. If there's no entry points, we call that convex. So that's the difference between convex and concave. So in these examples, we have a shape, and we're going to say whether it's a polygon or not. And so I see this shape, they're all straight edges, so I would say yes. Yes, it is a polygon. Now what's it called? It has 1, 2, 3, 4, 5 sides, and so I would call this a pentagon. Is this a polygon? Yes. How many sides does it have? It has 1, 2, 3, 4, 5, 6, 7. So I would call it a heptagon. If they asked, I would say it's concave. This one's convex. Is this a polygon? No. Why? Because it has a curved edge. To be a polygon, you cannot have curved edges. For these, we're going to say whether they're regular or irregular. So to be regular, it means all sides are the same and all angles are the same. So this one is irregular. This one, all 3 sides are the same. All 3 angles are the same. So this one's regular. This one, the angles are all the same, but the sides are not all the same. So this is irregular. Then tell whether it's concave or convex. This one would be convex. This one would be convex. And then because this goes in, I'd call that concave. So we're going to talk about the interior angle sum theorem. With the interior angle sum theorem, it'll tell you what all the angles in a shape adds up to on the inside. And what it equals is actually this. N minus 2 times 180. So you can put that there. So you take the number of sides, you subtract 2, and multiply it times 180. So for like a quadrilateral, I would take 4. 4 minus 2 is 2. And I would take 2 times 180, and that equals 360. So if you have a four-sided shape, the angles always add up to 360 on the inside. Now the reason why is because if you have a four-sided shape, so I'll use straight lines. If I have a four-sided shape, we call that a quadrilateral. This is irregular. How many triangles could fit in here? 2. So if you take the number of sides minus 2, that's how many triangles fit in the shape. So that's what this part tells you. It tells you how many triangles fit in the shape. So 4 minus 2 is 2, so 2 triangles fit inside the shape. So you have this 180 plus this 180, that's 360. For a hexagon, hexagon has 6 sides. So you go 6 minus 2 is 4. You take that times 180. And 180 times 4 is 720. So anytime you have a six-sided figure, otherwise known as a hexagon, all the angles add up to 720. So six-sided, if I make this my polygon 1, 2, 3, and this is not regular, 4, 5, 6, and I break this into triangles, so I'd have a triangle here, and a triangle here, and then a triangle here. So how many triangles fit in there? 1, 2, 3, 4. That's why this is 4. And then a decagon, 10 minus 2 is 8, so you take 8 times 180. Take 8 times 180, you get 1440. Now, if the polygon is regular, that means that every angle is the same. So if it's regular, then you could just divide the sum of the interior measures. You could divide these numbers by the number of sides, because number of sides equals number of angles, to find the measure of each interior. So for example, we're going to copy the same thing. We just said 4, 6, and 10 was 360, 720, 1440. So I'm going to put down here 360, 720, and 1440. But if it's regular, if it's a regular quadrilateral, which we actually call that a square, if it's a regular, we could take 360 divided by 4, and you take 360 divided by 4, that means that every angle is 90 degrees, which makes sense because a square has 90-degree angles. If it's regular and it's a hexagon, you just take 720 divided by 6, and you get 120. And if it's a decagon, you take 1,440 divided by 10, that'd be 144. Now what's interesting, this is called the exterior angle sum theorem. It's like if you take a triangle and you were to extend a side, and extend a side, we call those exterior angles. And no matter what the shape, they always add up to 360. So it could be a triangle, a pentagon, a hexagon, a septagon, an octagon. all the exterior angles always add up to 360. And that's what this says. So if you want to find the measure of an exterior angle of a regular side, you divide it by number of sides. So find the sum of the interior angles of each pentagon. So I take 7 minus, or pentagon is how many sides? Let's go figure out what a pentagon is. Pentagon is 5 sides. And they want interior. So I take 5 minus 2 times 180, which is really 3 times 180, which equals 540. And they want the sum of the interior angle measures. So they want all of them. Octagon, that's 8 sides. Subtract 2 times 180. So whatever 6 times 180 is, that's 1080. A nonagon, maybe you forgot what that is. Go up to nonagon. Nonagon's 9 sides. So you do 9 minus 2. Times 180. Which is 7 times 180. Which is 1260. Now here, find the measure of each interior angle. If it's regular, so pentagon, I have to take that 540 divided by 5. 540 divided by 5 is 108. So each angle is 108. Heptagon, it almost tricked me. Heptagon, I have to find the measure of all of them. So I'd have to take heptagon, I think is 7. Yep, heptagon 7. So I take 7 minus 2 times 180. See what that is? That's 5 times 180. 900. And then I have to take 900 divided by 7. And 900 divided by 7 is 128.57 degrees. A 15 gone. I have to take 15 minus 2 times 180, which is 13 times 180. That's 2,340. So that's the measure of all the angles. To find the measure of one angle, I take 2,340 divided by 15, and that'd be 156. Here, find the measure of each exterior angle. Now, all the exterior angles always add up to 360. So if they wanted the sum of all the exterior angle, you'd say 360. Sum of all, 360. But here, you just take 360 divided by 4, because quadrilateral has 4 sides, and that gets 90. Here, 360 divided by 8, because octagon's 8 sides. And so each exterior angle would be 360 divided by 8, 45 degrees.